Chapter 5.1 Parabolas. Okay, in this chapter we will learn about parabolas. So parabola is this. Actually, when we have an equation like this, y equals x squared, okay, we know the graph of this actually. So let me explain the graph. Okay, this is x-axis. Here is the y-axis. And x equals 1, y equals 1. Okay, if x equals 1, y equals 1. X is negative 1, y is negative 1. And the graph looks like this. Up. Like this. Okay, and then in this case there's a very important concept, which is okay, there is a focus somewhere between this vertex. If it opens upward, then the focus is somewhere above this vertex, and there is a directrix. We call it directrix. Let me draw a horizontal line. So actually the graph is this. The graph is there is a horizontal line, so that for any point, the distance from the point vertically to the directrix, okay, we call this one directrix line. Directrix horizontal line, and there is a point focus, so that okay, let's say this is the focus. Okay, let's say this is the point P, which means focus. So the distance from the focus to the point, okay, let's say this is a point P. This is the point XY. So that the distance between the focus, let's use F for this one, F. To the point, and from this point to this point. So let's say this is a directrix point. Then if this is X, then Y is, okay, so let's use okay, small p. Okay, let's use a negative p, small p. Okay, this point is a small p, negative p. This is large point. This is small letter p. Let's use a small letter p. Okay. So what I did is I just shown you a graph. So there is a focus point P and the directrix that is always opposite to this, opposite the other direction to this point, so negative P. So that from this point on the curve, and the focus should be equal to the length of this point and the directrix. So this graph is always the same. So if here's a point, then this length should be equal to this length. This is not drawn in scale, but it looks like this. So parabola is the set of all the points, so that the focus to the point, the length between the focus and the point should be equal to the length of the point and the directrix, always. So this should be 90 degrees. So that is y equals x squared. So we can rewrite this as y is equal to 1 over 4p x squared. This p is the focus. The value of p is the focus over here. I just redraw the graph so that it's more reasonable. Here's a parabola. The curve is the parabola, and this parabola is set because it's a set of all the points, so that the length between the two points F and A is same as the length between the points A and D. So this is the directrix. This is the point. It's a vertical line that forms a vertical line to the point on the curve. So based on this, the directrix is a horizontal line. And the y-intercept between the horizontal line directrix is negative p, and p is the focus. Okay, p is the focus. So when you graph a parabola, there must be a focus and directrix. The directrix is from the vertex of the parabola. The p-value and negative p-values are the same. So negative p is in the other direction, same distance apart from the vertex. And then so y equals x squared. X squared can be written as y equals 1 over 4p times x squared. Okay, let's prove this. So basically the length between 2 points FA should be equal to the length between A and D. So using a distance formula, FA, the distance from F to A is square root of x2 minus x1. So x minus 0 squared plus y minus p squared. So this is the distance between F and A. That should be equal to the vertical distance, which is AD. Okay, AD is, the x value same, only the difference is the y value. So there will be y plus p. Y plus p is the vertical distance, AD. So let's simplify this. So we can square each side. Okay, this one will be x squared, and this will be y minus p squared. So square each side. Square each side, then you can get rid of the square root. So we have the expression inside the parenthesis, inside the square root symbol. The right side is we can make it y squared plus 2ab, 2 times py plus p squared. The left hand side is x squared plus y squared minus 2 py plus p squared. So that is equal to, write the right side again and simplify this. Here's the y squared, y squared, y squared, y squared. Y squares are on both sides, so we can get rid of it. So x squared minus 2py is equal to 2py. Move minus 2py to the right, then it will be 4py. And rewrite this, so y equals something, then divide each side by 4p. So we have 1 over 4p x squared. So it looks like this. The value of p represents, this is the focus. This is the focus, the one on the y-intercept in this case, the y value. So actually when x equals 0, y is p, focus. So let's keep in mind this, y equals x squared. Actually y equals x squared, but the coefficient should be 1 over 4p, so that we can find the value of the focus, p value. So if y is equal to x squared, then the p value will be, so 1 over 4p should be equal to 1. So this means the coefficient is equal to 1. So the coefficient 1 should be equal to 1 over 4p. This implies that p equals 1/4. So p is 1/4. So if the graph of this will be, the focus will be 1/4. This is 1, then 1/4 is this one. This will be the focus. The graph looks like this, and then this part is negative. This is the directrix, negative p, x-axis directrix. So all the points on the curve will have the same distance. This will be the same for this point, so this will be same. Okay, let's consider two different parabolas. Okay, the first one is y equals x squared form. Y equals x squared form is the one that we know is up. The the parabola is opens upward or downward. So if the leading coefficient is positive, then it opens upward. So that means P is positive. If P is positive, then the graph opens upward like this. If P is negative, then the leading coefficient is negative, so it opens downward. Opens downward like this. So without a question, we can do this way. But if you replace x and y, interchange x and y, then that is inverse. That's an inverse. So the graph will be this. If P is positive, then this graph opens to the right. Opens to the right. Like this. If P is negative, then the graph opens to the left. X, Y, it opens to the left. So based on the sign of P, the graph is upward, downward, opens right, and opens left. And then depends on the function y equals x squared, and the inverse function x equals y squared. Then the graph is opens upward, downward, or opens right or left. Okay, so from this we can say that if it opens upward, then the p value should be inside the curve. So this is a vertex, so this will be the p value. For this, the inside the parabola will be the p value, the focus. So this will be minus p, right? Minus p, negative p. And this will be positive p, and this will be negative p. So we can find the focus. So focus is the same as the value of p. And then the directrix is in the other direction. So same distance from the vertex. So for this, this is the directrix, y equals negative p. This is negative p. Even this one, so this will be the directrix, the horizontal line in this case. Then this will be, the directrix is y equals negative p. And then even this one, so same distance from vertex to the focus, so this will be the directrix. Then this time, this is a vertical line, so the directrix will be x equals negative p. So same distance from the vertex to the focus, so this will be the directrix. So that equation is x equals negative p. So already, okay, example 1. Okay, let's find the focus and the directrix of this quadratic function. Okay, first of all, let's use, this is the form of y equals 1 over 4p x squared. And the coefficient of x squared is negative 1p. Negative 1 over 2. So negative 1 over 2 should be equal to 1 over 4p. So let's find the focus p from this equation. Then we can do cross multiply. So 4p is equal to negative 2. So p is equal to negative 1 over 2. So p is, the focus is negative 1 over 2. So if we graph this one, then something like this. Okay, p is negative. P is negative value. So the graph is, the p is negative. That means the coefficient, the leading coefficient is negative. So the graph opens downward, like this. Opens downward. And p is the focus, so this will be the focus p, which is negative 1 over 2. Then the directrix is the same distance away from the vertex to the other direction, so positive 1 over 2. So that will be the directrix. So the directrix is x, this horizontal line, so y is equal to 1 over 2. So that's the directrix, equation of the directrix. And the focus is this one, so the focus is when x equals 0, y is negative 1 over 2. Okay. So it's not really difficult. What you have to do is set an equation so that the leading coefficient is equal to 1 over 4p. Then solve for p. Then that is the focus. And focus is always inside the parabola. And directrix is outside the parabola. Okay, example 2. Let's find the equation of the parabola with the vertex is at the origin and the focus is at negative 2 and 0. Okay, let's graph this one so that we can understand much better. This x-axis, y-axis. Okay, the focus is at negative 2. So negative, let's say this negative 1, negative 2. This is the focus. And the vertex is the origin. This is the origin. This is the focus. So the graph looks like this. The graph is open to the left. Open to the left. So if we have a graph, parabola opens to the left, then this is the form of x equals 1 over 4p y squared. Interchange x and y. So if a graph is opens, right or left. Right or left. Okay, right or left. Look at this. Let me give you a hint. Left opens left or right. Then this one looks like what? This one looks like letter x, isn't it? Letter x. So the graph, the formula will be x equals 1 over 4p y squared. Does it make sense? So if a graph opens to the left or right, then that looks like letter x. So the equation is what? X equals 1 over 4p y squared. Okay. So we can use this form, this equation, x equals 1 over 4p y squared. And since p value is given, p is negative 2. So why don't we just plug in negative 2 for the p variable p. So x is equal to 1 over 4 times negative 2 y squared. So x equals negative 1 over 8 y squared. So this is the equation. Or you can write it, you can move negative 8 to the left. So it can be also negative 8x is equal to y squared. Actually, it doesn't matter. So this equation is fine. Okay, now let's consider a translation of the parabola. So when you translate parabola, we can translate actually the vertex so that everything goes along with the vertex. So once we move the vertex from the origin 0, 0 to a coordinate h and k, then it looks like this. Okay, y equals 1 over 4p x squared. So this is a parabola, opens upwards. Let me change this. The graph will be like this. So this is the graph in parabola. So when you translate this one to the right, or get k units horizontally and h units vertically, then this will be, okay, I think I graphed incorrectly. So let me graph it again. So this is y equals x squared. This y equals x squared. So actually 1 over 4p x squared. So translate h units, let's say h units to the right or k units up. Then this vertex will be moved this much to the right and this much up. So the graph looks like this. Then the equation for this is this guy. So what you have to do is replace y with y minus k, and also replace k with x minus h. That's it. So this means the vertex 0, 0 has been shifted k units horizontally and h units vertically. So this will be the new vertex. Because I redraw the graph, so it's more readable. Okay, so what we have to do is just replace y with the y coordinates and x with x coordinate, x minus h. So y will be replaced with y minus k, x will be replaced with x minus h. So that is how we translate graph opens upward. Okay, how about the graph opens right or left? So if we have a equation like this, not this one, interchange x and y. So x is equal to 1 over 4p y squared. Then once you shift this one to the right and left, or horizontal and vertically, then it will be something like this. X minus h is equal to 1 over 4p. Okay, y will be replaced by y minus k squared. So we are translating the graph, actually the vertex, from 0 to 0, 0, 0 into hk. So if you graph it, it looks like this. Okay, so this is y. Okay, when p is positive, it looks like this. So we want to translate it. So the vertex will move h units horizontally. Let's move to the right. H units horizontally, and then k units vertically. Then this will be our new vertex. This will be the new vertex, so the graph should be something like this. Example 3. Okay, let's find the equation of the directrix and the vertex and the focus of the parabola of this equation. Okay, look at this. The equation, the exponent of y is squared. Y squared. So we have to rewrite it as x is equal to 1 over 4p y squared. Okay, so the graph will be something like, it opens right, opens left, or opens to the right. It looks like this. The graph should look like this. So the focus will be, the p-value will be here or here. And directrix will be on the other side. So let's factor this equation. So not to factor, make a square for x, for the y variables. So when we do completing the square, we can use the completing the square. So do you remember completing the square? If we have, let me write it on the right side. For the completing the square, okay, let's say here it is x squared plus by. Then we need a constant, so that the constant will be b over 2. Okay, divide the coefficient of x. Sorry, this should be x. Divide the coefficient of x by 2 and then square it. So that goes over here. So that this looks like x plus b over 2 squared. So we're going to use this property, completing the square method. So we have a y squared and y. So we need these two terms. Okay, so that is, okay, let's make it 2y squared. Let's rearrange it. 2y squared plus 8y is equal to, move other terms. So 3x to the other side, negative 3x, minus 4 moves to the right, so plus 4. So what we need is a square, the binomial square of a binomial for the variable y. Then from this, you can factor out 2, then y squared plus 4y inside the parentheses. Let me give a little bit more space. So that is equal to negative 3x plus 4. Okay, from this, let's add something and subtract something inside the parentheses. I want to make this y squared plus 4y plus something to be a square. So divide this 4 by 2. Divide 4 by 2 squared, which is equal to 2 squared. So we can add 2 squared So since we added something, we have to subtract the same number. Subtract the same number. Okay, then rewrite the equation. So this will be y. The first three terms will be x plus 2 squared minus 4. Okay, let's use bracket. 2 times bracket, and y plus 2 squared minus 4 is equal to negative 3x plus 4. Okay, then you can distribute, so it will be 2 times y plus 2 squared minus 8 is equal to 3x plus 4, and then 2y plus 2 squared, move minus 8 to the right, then 4 plus 8 is 12. Okay, and then you can, why don't we factor out from the right hand side of the equation, factor out negative 3, then x minus 4, and then divide each side by 2. So we have a form like this. So is this form same as this is what we want? So if you rewrite it, it looks like this. Negative, okay, let me rewrite this one more time. Okay, let's divide it by negative 3 instead of 2. Let's divide by negative 2. That is better, because we want to write x term on one side. So divide each side by negative 2, negative 3, so negative 2 over 3. Then if you rewrite this, then the left hand side is x term, the right hand side is negative 2/3 y plus 2 squared. Now I want to write this one in the form of this. Y is equal to 1 over 4 y squared. This is what we want to write. So as you compare this, okay, this x is replaced by x minus 4, and the y variable is replaced by y plus 2. So the vertex, so from this the vertex is 4 and negative 2. So because x is replaced by negative 4, x minus 4. So 4 is the horizontal shift, and y plus 2 means y minus negative 2. This means y minus negative 2 squared. So vertical shift is negative 2. So the vertex will be 4 and negative 2. So if you graph it, then it looks like this. Okay, look at this. Okay, let's find the focus. The focus is this. 1 over 4p should be equal to the coefficient of this y squared. So negative 2 over 3. So from this equation we can find p. Cross multiply, so negative 8p is equal to 3. So p is equal to negative 3 over 8. So the focus is negative 3 over 8. So if we graph this one, we are moving the vertex to 4 and negative 2. Okay, since the leading coefficient is negative, negative 2 over 3 is negative, so the graph is opens left. Opens left. This is original graph, opens left. This one is shifted 4 units to the right. 1, 2, 3, 4 units to the right, and 2 units down. So this will be our new vertex. So the graph looks like this. The graph looks like this. And then the focus should be over here inside, inside the graph. And this distance is negative 3 over 8. So this is negative 3 over 8. Negative 3 eighths. So actually this focus, the focus will be, okay, from the vertex. Vertex is 4, and then the focus is negative 3 eighths, 3 eighths less than 4. So we will subtract 3 eighths because 3 eighths away from the vertex. So there will be the x value. So this will be the x value, right? Okay, so this will be the x coordinate of the focus, and the y coordinate is, okay, y is, the vertex is moved down 2 units. So the y coordinate is negative 2. Then the actual focus will be 4 minus 3 over 8 is, okay, 4 will be 32 over 8. So 32 minus 3 is 29 over 8, and y coordinate is negative 2. So that is the focus. And the directrix. The directrix is where? Is on the other side. So directrix will be on the right of this vertex. So this will be the directrix. And the distance is still same, 3 eighths. So the directrix is x equals, this vertical line. So x equals, there should be 4 plus 3 eighths more. So the vertex, so the directrix is 3 eighths more than 4. 4 is the x coordinate of the vertex. So that is equal to 32 over 8 plus this, so 35 over 8. So the directrix is x equals 35 over 8. Directrix, the equation of the directrix, the focus is this one. And the equation is, so the equation is this. This is the equation. Example 4. Okay, directrix and the focus is given, so that let's find the equation of the parabola. So let's graph this one first so that we can understand easily. X-axis, y-axis. The directrix is negative 1. Negative 1 is a vertical line, negative 1. So this is the directrix. And the focus is 3 and 2. So 1, 2, 3, x is 3, y is 2. So this is the focus. Then let's check on this one. This is the focus, and this one is the directrix. Okay. Then we need to find the vertex. The vertex is always between the directrix and the focus. It's in the middle. So it will be over here. So the distance from here to here is 1, 2, 3, 4, isn't it? 3 minus negative 1. So the distance is 4. So the midpoint is 2. So 2 distances away from the directrix and the focus. So this will be the focus. This point will be the vertex, because the vertex is in the middle. Okay, it's in the middle. So the graph looks like this. Let's use a different color. So the graph looks like this. And this distance is 2. So this is 2. So actually 2 means the focus, right? Focus is 2. 2 means 2 units away from the vertex. Even this one. This distance is 2. So P will be the focus will be 2. Okay, so now the vertex. We know the vertex is now x equals 1, y is 2, and the focus is 2. Okay, for the vertex, okay, the vertex is the midpoint. So let me get the midpoint of 2 points. So the vertex will be, the x value will be sum of 2 values, 3 and -1. So 3 is the x value of the focus, and -1 is the x value of the directrix, divided by 2. And y value is 2. So this will be the vertex. So 3 minus 1 is 4, 2 over 2 is 1. So that's the vertex. And then the graph is opens to the right. So the equation should be x is equal to 1 over 4p y squared. And p is the positive number 2. So just rewrite this. So replace this x and y, p. So x will be replaced by, so from this, the equation is this. The graph is shifted 1 unit to the right, so replace x with x minus 1. 1 over 4, p is the value, p is replaced with 2, and y will be replaced by y minus, the vertex moved 2 units up, so y minus 2 squared. So that's the equation. Or if you rewrite it, okay, so if we rewrite it, then it will be 1 over 8 y minus 2 squared, or you can multiply each side by 8, so it can be 8 x minus 1 is equal to y minus 2 squared. So either one of these two will be the equation of this parabola. So what we did is, okay, as a summary, okay, graph this based on the given information, directrix and the focus. And the vertex is between, right in the middle, between the focus and the directrix. So find the vertex, and then by looking at the graph, the shape of the graph, the type of the graph is opens to the right or left, then that equation is x equals y cubed, y squared. X equals something y squared. So from this equation, apply the transformation property. So replace x with x minus h, replace y with y minus k, and also replace the p-value. Then rearrange the equation, then this will be the equation of the parabola. Okay, the parabola can be used for satellite dish, because the satellite dish, if a signal comes to the satellite dish, then the signal will be collected on the same point, which will be called the focus. So if you see the red one, the red line, the red line is signal. So once the signal comes and then touches the satellite dish, then there is a point. So you will touch the point on the satellite dish and then bounce, so that it goes to a focus. And the angle for the bounce is same. Actually, it's the same, which means, okay, here is a tangent line. Here's a line tangent to the point P. Okay, this is the tangent line. And the signal bounces so that the angles, like angle A and angle S. Here's one angle, and the other side is also the same angle. So it will go to a point F. And also, if a signal comes, here's another signal going down. Then here's a point, let's say Q. So here is a tangent line tangent to this point Q, and the ray bounce so that it goes to a focus here. So the parabola can be used for the satellite dish. So satellite dish, the shape, the curve looks like a parabola. So we can use a formula like the equation y equals 1 over 4p times x squared. Okay, let's try an example 5. The example 5, Okay, satellite dish, the diameter of the satellite dish is 8 feet and the depth is 1.25 feet. So from this, let's find the focus so that the focus will collect all the signals. So let's draw a little diagram. So let's say the vertex is the origin. Okay, the vertex is the origin. And then let's say this is a satellite dish, the shape of the satellite dish, X, Y. Okay, by looking at this, the diameter is 8 feet. Diameter is 8 feet. That means that is 4 feet away from the origin. 4 feet away from the origin. And since the depth is 1.25, so this will be 1.25 feet. So from this, we have 2 points. And this point is x is 4, y is negative, y is 1.25. Since we have a point, we can use the satellite dish looks like a parabola, so we can use the parabola formula, y equals 1 over 4p x squared. So let's plug in this point so that we can find the focus p. So we want to find the focus, which means the value of p, right? P. So y is 1.25, x is 4 squared. So that is, okay, cross multiply, then 5p is equal to, the right side is 16, and p is 16 over 5. So p equals 16 over 5 is around 3.2 feet. So you can make okay, if you have a parabola like this, then you can put a focus, antenna. The focus should be over here. So this will be 3.2 feet away from the vertex. And this is the satellite dish. A satellite dish like this. Okay, let's summarize the parabola, the graph of the parabola and the equation. Okay, first of all, we can have y equals 1 over 4p x squared. Okay, the coefficient is 1 over 4p and x is squared. So from this one, we know the graph is concave upward or concave downward, always, because this is quadratic. So there's no doubt, so that if p is positive, that means the leading coefficient is positive. So the right end is up. So this is the graph of what? Graph of concave up. Always concave up. And if p is negative, that means the leading coefficient is negative. So it will be, the graph will be concave down. Okay, so actually this is the origin. The vertex is at the origin. X-axis, y-axis. So the vertex will be at the origin. So y, the equation starts with y, right? Starts with y. So let me write down y. Y looks like this. When you write y, we should, it starts with U-shape, right? U-shape. So if an equation starts with y, then the graph is either upward or downward. Concave upward or downward. Okay, if we interchange x and y, then the equation will be x is equal to 1 over 4p y squared. Okay, the graph of this is, okay, as I mentioned earlier, okay, x, the equation starts with x. X looks like this, right? X looks like let me redraw it. So x looks like this. So the graph is open to the left or open to the right. So here is x-axis and the y-axis. Okay, if p is positive, then the graph opens to the right. If p is negative, then the graph opens to the left. So keep in mind that if the equation starts with y, then y looks like, y starts with U shape. So the graph is either concave up or concave down. If the equation starts with x, is parabola equation starts with x, then x looks like opens to the left, opens to the right. So we don't have to be confused with the graph. So by looking at starting with y, the shape of y and the shape of x. So those shape of x and y shows whether the graph is concave up or down, or concave, opens to the right or to the left. Okay, and also the shift. When we shift, so the graph of this 1 over 4p x squared, just what you have to do is, let's say shift h units horizontally and k units vertically, then the new function will be y minus k. Always replace y with y minus, and then x with x minus h. Okay, if the equation starts with x, then the graph should be opens toward to the right or to the left. Then you can shift this one horizontally and vertically. Then the new equation will be x minus h is equal to 1 over 4p times replace y with y minus k. So the first equation is the graph for shifting the graph of the graph looks like upward or downward. So this graph will be shifted horizontally and vertically. For the second equation, the graph opens left or right. So shift this graph horizontally and vertically.